Oh no, I'm going live. I'm not live yet. Okay, now here we are. We're going to do questions on section 1.2. I don't know if these will be your questions, but perhaps you can get some things out of it. If we don't answer your questions, text me, call me, something. Okay. All right. So in section 1.1, would you like to if you got anything that you couldn't do, you didn't understand what to do, or you got it wrong and you don't know why? Anybody? Yeah.
So like, when it's in like the like the rule form, like, I don't know, linear, like f of x equals 3x or something.
Can you give me a problem number you'd like me to look at?
Yeah, let me look.
Okay, that's fine.
Like 21.
Okay, the instructions are graph the function and its parent, then describe the transformation. So 21 is f of x equals 2x squared. Okay. And on Big Ideas Math, do they give you a grid to graph it on?
Sometimes like 2 or 3, like one.
Okay,
question.
but this instruction says to graph, so they give you a place to graph it, or do you have to choose one?
We have to choose one.
Okay, have you got it pulled up right there? On Big Ideas?
Yeah.
Huh?
The book.
Oh, but you don't have the assignment.
No.
Okay, so they may give you 4 choices and they say which one shows the parent function and the, okay. This 2 right here, the parent function is just x squared, and this 2 right here will do what to it? Is he right?
No, because shrink
is stretch. It's like fractions.
So will it get narrower or fatter? Narrower, because it's like somebody took that parabola and went like this with it, because this is greater than 1. Okay? So the graph that you choose should look something, there's no transformation, by the way. There's no moving right or left, there's no moving up or down, there's no numbers being added in here in the function, there's no numbers being added out here. The only thing that's going to happen to this thing is going to get narrower. So it's still going to be located in the same place as far as the turning point, but it's going to be slightly narrower. So the graph that you should choose would be something like this. If this is the original parent function here, then the daughter function graphed along with it on the same graph should look something like that. It's going to be narrower.
So like when it goes up and down, how do you know it goes like up, down, or left or right?
That has to do with the sign on this multiplier. If this were negative, then it would not only be narrower, it would start here and open downward. The blue one would. But since it's positive, it's going to open in the same direction as the original. It's just going to be narrower because it was stretched like a rubber band. So it should look something like that for your choice of graph. Okay? And then it also says to describe the transformation. In this section, we're not describing how big of a shrink or stretch it is. We're just saying it's a vertical stretch. And we choose stretch because that's greater than 1. Is that okay?
Yeah.
In the next section, we're going to take a little bit of a leap. That's not the only leap we're going to take, but in the next section, we would say it's a vertical stretch of 2. So we're going to actually identify it by the number next time. There's other things we're going to be doing in this next section too, though. Does that help at all?
Yeah.
Okay. Any other questions? Yeah.
So how do you know if it's like for the range? How do you know if the range is all real numbers or if it's like the number like after it?
The range pertains to the y values.
So if it's going to hit the y?
No, not if it hits the y. You got to think of this as a number line that somebody just took like this and stood up, with the positives up here and the negatives down here. And the question is, which of the numbers on this number line, are expressed in the graph? So this one right here, maybe a number 2 is expressed right there, and there, and there, and there, because you go this way, you can hit it. And all of these, all 4 of these spots, this, and this, all 4 of those spots right there have this for a y value. And so that y value exists. This y value. Right? Because this y value, you go right and left to try to hit the graph, you'll never hit it. it begins to have values right here. And so the range on this number line, which is positive up here, negative down here, the range on this number line is from 0, including 0, up, which is y greater than or equal to 0, because we're considering y values which are expressed in the graph. Does that make any sense? Okay, yes.
So what would it look like if it was all real numbers?
A graph or a range with all real numbers? Here is, you guys haven't seen this shape of a graph yet, but just to have something a little less boring than a line, lines have all real numbers. They hit every single y value down here and all the ones up here, and even goes this way, they hit all the negatives down here and all the positives up here, you know what I'm saying? But a graph like this, if it has arrowheads here, that has a range of all real numbers because it continues up like this forever, it continues down like this forever. Every single y value that you want to hit, if you go out right or left far enough, you'll hit the graph.
So if it's like the diagonal line, then it's gonna be all the numbers.
Sorry?
So if it's like the diagonal line.
Yeah, or going the other direction. Yeah, if it generally fits top to bottom like this, like a line or something like that, or if it goes this way, yes, it's gonna be all real numbers. But this one doesn't. It comes down and then it goes and then it bounces off and it never hits these guys.
So absolute value would be all real numbers, or
The domain would be, but not the range. The range is never all real numbers for an absolute value. Because an absolute value behaves like this. It bounces off someplace. This one would have a range which is from here. Do you see what I'm saying? Okay. It's excused, so just leave this right here. We gotta remember that. Oh, actually, we don't have to change it. If they bring one in from the office, not some other teacher, then they've recorded it. They fixed it. Okay. Does that make sense to you? Absolute values and quadratics never have a range that's all real numbers, ever. Lines do, all the time. Constant functions only have one value for their range, because they only hit the one y value that's ever expressed. Do you understand the summary?
Yeah.
Okay. Any other questions? These are all good questions. Excellent. Yes.
On number 25.
Yep.
How would you go about doing that?
H of x equals 3 absolute x. What's the parent function for this? Absolute value of x? What is different from this compared to the parent? What makes this different? Okay, don't describe the graph. How is this different?
It's the opposite.
it's got 3.
How is this different from this? This is the parent function. I'm talking about the writing of the actual function this way. What makes it different? The 3. So now the question is, it's the 3 that makes this expression different from this one. What does that 3 do to this graph if you were to graph it?
Vertically stretches it.
Very much like this did, vertically stretch. I don't know, I'm going to call this 8 so that I can call this f, the parent function. See, this is different from this by that 2, and it vertically stretched it because it was a positive 2. This is also going to vertically stretch it. It's going to make it narrower. But it's not going to move it anywhere, and it's not going to tip it over. This would have to be negative to tip it over, to make it open down. And there would have to be something either added in here or out here to move it somewhere. It's not moving, it's not flipping, it's just stretching. So very much like that one over there, the graph of this would be the parent. And this would be the daughter, the stretched one. It's going to be narrower. It's going to go up 3 and over 1 instead of up 1 and over 1. But they're both going to start from the same place, so they both have the same domain in them. Make any sense?
Yeah.
Okay. Good. Any other things you want to discuss?
The parabola and the absolute value, those are going to be like sides.
Yes, but. Big but. In here and in most of your high school math that you will discuss, we will discuss only functions. And if you have a parabola that opens up like this, and they do have these. It's a whole chapter called conic sections in Algebra 2. We hardly ever get to it. But if you have one that opens up like this is no longer a function because it fails what we call the vertical line test. The vertical line test means there's this is a loaded question. You're going to get this lecture again later. But if you can draw any vertical line that only hits the graph once, just one time. Now I realize I'm hitting the black and the blue here, but they're separate functions. So if I erase this and I talk about just the parent graph for just a minute, as in this context of what we're saying here, there is no vertical line that you can draw that will hit that graph more than once. at all. But it cannot hit more than once. This one, every place hits twice. This is a non-function. And we don't discuss those in here. Okay? So yes, the answer to the question is they will always open upward for us. As a matter of fact, right soon, I don't think it's this chapter, I think it's next chapter, I don't know. They will discuss these, the book will discuss these, but we will not. I'm eliminating that part because we don't have that just functions in. Okay, good question. Anything else? Okay. Do any of you need to know if you got your answers right? The odd ones are all in the back. Did anybody check those as they went along? If you didn't check them, then check them and let me know if you got a yes after you check them. And in the future, if you do assignments on paper, check the odd ones in the back. I will tell you what the even answers are, so we don't have to waste a lot of time reading answers. Does that make sense? So I'm going to tell you what the even answers are. There aren't any. Yes, there are. 2 even ones, 4 and 6, and 8. Sorry, 3 of them. I'll tell you what the even ones are, and then you go back and check the odd ones and let me know. Okay. Number 4 is quadratic, and this is what the book says is the description. Just see if you've got something, a gist of this. The graph is a reflection in the x-axis.
Retention, they're ready to start sophomores, last name A through F, to they'll have your picture taken. Sophomores A through F, go to the auxiliary camp.
So it's a reflection of the x-axis, a vertical stretch, and a translation up by 3. The domain of each function is all real numbers, but the range of f is y less than or equal to 3, and the range of the parent quadratic is y greater than or equal to 0. So the ranges are different. Number 6. Number 6 is a constant function. The graph is a translation 2 units up from the parent. Even though it's at 3, it's an up 2 from the 1. So it's a translation up 2. The domain of each function is all reals, but the range of f, the new one, is y equals 3, and the range of the parent is y equals 1. So the ranges are different. And number 8 is quadratic, and that's all you had to do on number 8. Okay, so those are the answers to the evens. If you did not grade your odd ones, do that one and then turn it in once you've graded it, because I will grade a few of them, and if I find that you're trying to lie to me when you turn your paper in, that's going to be a big problem for you and me. So if you're sure you got, let's see, there were 29 problems, you can miss 3. So if you got 3, if you miss 3, 2, 1, or 0, and you're sure of it, turn it in, if it's on paper. If you're not sure of it, or you've got some that you have to fix yet, then, and I see your graph, so you don't need to turn your graph paper in.
Okay.
Yep, it looks like you gave it a good effort. Fine, that's good. I just want to see that you graphed something when you were asking. Okay, and so you can just turn the paper in. I've already seen your graphs. Saren and what's your name? Blake. Just turn those in.
Yes.
The rest of you get them submitted on computer, and I will send them back to you if you didn't get a 90% or better. Any other thing about section 1.1 or anything about how I'm running class so far? So we're ready to move on? Okay, here we go on section 1.2. This will involve the same things we did yesterday, only in greater detail, and you will have to pick up a few new skills. Maybe not new, but you'll have to be reminded of a few skills about function and function notation. Whenever I say the word notation, it refers to how we write things to get our ideas across in that. So you're going to have to learn something about the way we write things to express certain ideas. And I have a little note to myself right here that I need to review a few things with you. So I want you to consider with me for a few minutes this function. It's a nice linear function. It's not the parent. Let's say 3x minus 5. Do any of you know or remember or would like to try and tell me what this, with respect to this function, what this means to do? It's something you do. It's math that you do, but you have to know what the notation means in order to do it.
Double it.
That's a good thought. Excellent volunteer. Incorrect. It's okay. I'm glad you volunteered. That's great. That's good though. Conjecture about it. Does anybody know or can think of what this means to do? Yes. The x becomes 2. That is correct. That's okay. Because right here, you see in this notation, this means the y value. And people always look at that and go, why didn't you just say y then? Because of what Jasmine just said. This says, what follows this has x's in it for a variable. This says, the x's in this thing over to the right need to become 2, because x changed to a 2, this x must change to a 2. It means plug it in. Plug a 2 in. That's what it means. And so this would be 3. This is what you would think in your head, or you could write it down, 3 times 2 minus 5. And then you do the arithmetic. You multiply first, and then you subtract, and that is 1. What's that? What that means, folks, is this. On this linear function, by the way, how many points are there on a line? It takes 2 points to determine a line, but how many points are on the line? An infinite amount.
Yeah. I was like, what?
Yeah, too many to count. Billions and trillions and too many to count. One of those too many to count points is the point 2, 1. That's what we've discovered. When x is 2, y, this thingy, is 1. So another way of writing this is to say f of 2 equals 1. This is another way of writing a point. It's a new way. This is notation. When x is 2, y, meaning f of 2, is 1. In other words, our points are made up of these, an x value and then f of x value. This is your y value. It means the value, the number that kicks out when we plug this in to the function. Now we could find billions and billions of points, probably rather quickly with a computer, by plugging in all sorts of values of x. String them together like pearls, and you get a line once they're all strung together. You get this line. You see what I'm saying? And so this notation says, what is y? This is asking, what is y in this function when x is 2? The answer is 1. So that's one of the millions of points on the thing. It's kind of looks like that. This is another way of writing it. F of 2 equals 1 in this function. You follow? Okay, so let's try another one. Let's try to find f of negative 3/4. Does x equal 3/4 show up on this line? If x is negative 3/4, will it go with a y value on this line?
Yes.
Why?
I don't know.
It could go down or up, or it could go down, a line can go down or up.
Okay, can you talk to me mathematically? Why do we know that any number I plug in will have a y value? I'll get you started. Because the domain
It's
of
all
a
around.
line is all real numbers, which means any x I choose will work. So that's the math lingo that you would say that verifies, yes, it'll work, because the domain is all real numbers for this thing. So anything I plug in will work. So what is f of negative 3/4? What does that mean? What do we do to find the answer to this question? You plug it in. Yes, you plug it in to this. 3 times negative 3/4 minus 5. It is okay to use unprecise language in here as long as it's clear what we mean. Okay? Now, who loves to do fractional arithmetic, especially with negatives? Let me show you a workaround with these wonderful calculators I gave you.
Thank you for action.
By the way, these calculators that I gave you to use do not have an ABC key. It does not have a fraction key, but there's a workaround, and again, you got to know how to do it. So please grab your.
So have a picture taken, software G through M.
Oh.
So please grab your calculators and follow me. To type this in and make the calculator do all the grunt work with the negative sign and the fractions and all that crap, is what you type. 3, parentheses. Everybody there?
Yeah.
Then you type in, not subtract 3, but -3. Remember the difference?
Yeah.
Negative, because of that, 3, divided by a divide symbol, and it'll show up just like this. 4, close it. That's your 3/4. That's how you enter 3/4 as a fraction, with a divide symbol. Okay. -5. Got it?
Yeah.
Now hit enter, and it will give you a decimal.
Negative.
I don't want to know what it is. Don't tell me. But you all seem to be getting about the same thing, right?
Yeah.
We want the answer to be a fraction because the plug-in was a fraction. We stay true to the form that it was given to us. So now, here's how you change a decimal into a fraction. You hit the math key, and the first thing you see that's highlighted is FRAC for fractions. So you hit math, you hit enter, and it says, you want me to change this to a fraction? And you say enter by answering yes. So it's really math, enter, enter. What do you get? -9/4.
-29.
Oh. Negative?
29, yeah.
Okay, so what that means, folks, is even as ugly and gross and negative and nasty as that was, we know that the point, -3/4, comma, -29/4, is a point on this line. In other words, f of, this is how you answered, f of -3/4 is equal to -29/4, saying the same thing. And you get your calculator to do the grunt work if you realize that this means to plug it in. Okay, now the next one I'm going to give you, you're not going to like it, but just stay with me. It follows the same thing, only it's a little bit more strange. Same function. This is still our function, and I want you to find f of x plus 3. What does that mean?
We don't know what X is. So we don't know what X is?
We never know what x is. X could be a million things, and it kicks out a million different y's to go with them.
So can we plug that into what, or we don't know what?
Okay, plugging it in is a good word, except for it's a little bit ambiguous here because it's got an x in it. It means,
So it's what?
just a minute, hang on. Just like this meant to replace this x with a 2, and this meant to replace this x with a -3/4, this means to replace this x with x plus 3. And it looks like this. Be sure you stay true to the math behind it. It's 3 times this 3 right here, times all of this replacement. And if there's more than one term, you have to put it in parentheses. Because this is 3 times x. This has to be 3 times its replacement. All of it. You follow? -5. Then we've got some math to do. This answer isn't going to be a nice clean number or even an ugly number. It's going to be an expression. So it's going to be, we distribute, we get 3x plus 9 minus 5. That's 3x plus 4. And we say f of x plus 3 equals 3x plus 4. In other words, and this is very, in other words, this is a point on the line if we only knew what x was. So you follow that?
Is that your brother?
No. Someone else. So this was just like these, only the plug-in, when we replace what it is, it's a replacement for x. And if there's more than one term here, you have to have parentheses. Then you do the algebra and clean it up as much as possible, and this is your answer.
Can you graph that?
Possibly. Well, how do you graph that? You can't unless you give yourself a value of x, add 3, make that your x value, and then take 3 times that same x plus 4, and that'll be the y value that goes with it on that line. This is mostly about notation. I'll just turn it off. Okay? Do you follow or not really? You see what's going on? So if you have to replace x with an expression, you can expect an expression to be the answer. You're not going to be able to get a number out of that. But it's the same concept. You replace the x with what's in the parentheses. All right. There's one other thing I need to remind you about, some math that you may have known before or maybe not. Totally unrelated to this, so it's a different concept. I need you to be aware of the fact that the absolute value of a number times another number is exactly the same as, and they can be interchanged, they're interchangeable, is the absolute value of just the first one times the absolute value of the second one. They can be split up, and you can absolute value them individually. Okay? And the main place this is going to show up is if you have, for example, the absolute value of -3. I know what you're going, that's not two numbers, that's not an answer. Actually, it is. It's the same thing as the absolute value of -1 times the absolute value of 3. That's a -1 times 3. You with me or not? Okay, so what's the absolute value of -1?
1.
And 1 times 3, absolute value of 3 is? And you're going, I already knew that. The absolute value of -3 is 3. I understand that. But it will become important for you to be able to take these negatives and split them up in a few minutes. You'll see. I just wanted you to understand that this is the same as this, and it turns out to have the same answer as going directly. Just be aware of that fact. Okay, so for example, let me do this one with you. This is a better example than I just showed you with this, of where you're going to use this. If I ask you to find for me the absolute value of -x minus 3, no, let's make it plus 3. Watch carefully, this is subtle, important. This is the same thing as, first of all, staying inside here, it's the same thing as factor out a negative times x minus 3, because I took a negative out of both. This was negative, it's now positive. This was positive, it's now negative, because every time you take a negative out or work one in, everybody's sign changes. You with me? Yeah. Close it. That's the same thing as the absolute value of that negative sign times the absolute value of x minus 3, which is x minus 3. Now that might not be something that's quite so obvious, because the absolute value of -1 is 1 and doesn't count anymore as a multiplier. You might have, well, you probably will have a tremendous amount of difficulty going from here to here without this in between, especially the factoring out of the negative. Okay? To understand that this is the same as this is not intuitive. Not like the absolute value of -3 is 3. That's intuitive. You've been dealing with that for a long time. This, changing to this, without this intermediate stuff is very difficult to handle. So you've got to understand what's happening there. If there's a negative on your variable, you want to factor that out and then eliminate it with this property. It's going to come up. All right, so here we go. I just wanted to make you aware of those things so that when I use them, you'll understand that. Look at example 1. It says, let f of x equal 2x plus 1. We've got a nice linear function again. By the way, folks, I got to stay on this board in order to get all of this so that Nella can see it. So I'm just going to keep erasing and using this board up here. All right, so here we are in example 1. And f of x equals 2x plus 1. Okay, so there's our nice linear function like the last one I had up there just a minute ago, and this is what we are to do. In the A part, write a function g, so we're going to call it g, whose graph is a translation 3 units down of f. I'm going to show you the trick of getting these right every time. And if you try to shortcut it, when things get more complex than what we're doing here, you'll mess it up. So try to learn it on the easy stuff. We are to translate f 3 units down. Right? I am not going to write, I'm not going to do anything with this right now. I'm going to write in the proper notation what it means to move f 3 units down. It is this. That's what we're doing. When you move things up and down, remember I told you yesterday, I don't know if I told you this or if it was just 4th period, but whenever you move it 3 units down, it's on the outside of the function. Up, down moves are on the outside. Right, left moves are on the inside. Since we're moving it down, I put 3 out here, subtract 3. So that means, now I'm ready to bring this home here, that means that g of x is f of x, subtract 3, which is that. This tells you it was already up 1. If you're going to move it down 3, you're going to land at -2. And most people can see that when it's real simple. Skipping from here to here by using your intuition will get you through about a third of the assignment, and then you're going to run into trouble and start missing things. I recommend, while it's easy, and especially when it gets hard, that you do this. You say g of x is f in general minus 3 because that moves it down. Then you make it specific by replacing f of x with this and doing the arithmetic. Practice it that way with this intermediate step, and when it gets tougher, you'll have method. Okay? Yes?
So if I wanted us to left to right, you would do after and in the parentheses next one.
Almost. You're very, very close. I love it that you're anticipating this. It'll be next, the next one, because the next one says, there's a translation 2 units to the left of f. Okay? And that's what we're going to do next. We're going to call it h. So they're saying, let h be a translation 2 units left. And this is going to be, make sure you're paying attention here, because this will hang you if you don't pay attention. H of x is supposed to be f of, and you're right, right-left moves happen inside. And what are we supposed to do to it? Move it left 2 units. And this is not a mistake, folks. Add 2. It's got to be x plus 2. If you're doing a horizontal move, a horizontal stretch, shrink, a horizontal anything, flipping it over the y-axis is a horizontal flip. If you're doing anything horizontal, anything, it will take place inside the function and will be the opposite of what you think. Okay, so then what this means, and this is the reason why I showed that other part that I erased, to write this down, h has got to be, bringing this home to this specific function, has got to be 2 times x plus 2 plus 1. See? When it happens inside, you're going to have to write f of x plus 2, which means replace the x in f with x plus 2. That's what we just showed you a minute ago. Then we clean it up. That's what you write. So, horizontal moves, right, left moves occur inside the function, inside the parentheses, the opposite. Up, down moves occur outside, exactly what you think. Okay? All right, let's try let's try a reflection. Reflections are pretty easy. Example 2 that we're going to do says, let f of x be the absolute of x plus 3 plus 1. So we got another family of functions we're going to deal with in these transformations. Yep, okay, now, here's the A part. So this is the function we're dealing with, and this is what we have to do to it. Write a function g whose graph is a reflection in the x-axis of f. A reflection in the x-axis means wherever it is, it's going to go like this. Does that feel like a vertical reflection to you? It does me. It feels vertical because I'm tipping it from up to down. Horizontal would be this way. Does that make sense? A vertical flip. Over the x-axis is vertical. Vertical things happen outside the function. Up, down things on the y-axis, things that are happening vertically, are outside the function. So if I want to take this and flip it over the x-axis, it means to do this. I'm going to have this new function called g of x, and it is the opposite of f of x. Outside. This will flip it over the x-axis, vertically. Do you follow me or not? Vertical flip. That means, in particular, that that negative applies to the entire function, so it looks like this. Gross. That's nasty notation. Do y'all see what I did there? Gross. That negative belongs to the entire function. So I held it out and put the whole function in parentheses. Now I'm going to apply this with a distribution. It looks like this. This is one term, by the way. Even though there's a plus sign there, this thing and the absolute value is all wrapped up there in one little package. Looks like this. Because I'm distributing it to both terms. Okay? Now, if you want to check it out and make sure that it did flip over the x-axis, you could graph this and graph what you believe is the correct answer and see if it flipped over. You can check it to make sure that you got all of this stuff right. Okay? The next thing, the B part says, write a function h, a new function whose graph is a reflection in the y-axis. Okay, so if we reflect it over the y, what if it's over here and we reflect it this way, or if it's over here and we reflect it this way, does that feels horizontal to me? Horizontal things happen inside. And so h of x is going to be equal to f of negative x. This is happening inside. The reflection is a negative sign that's happening inside because we're doing a reflection over the y. Do you understand that? Which means that every x in f will get replaced with what's in the parenthesis here. Yeah? So I'm going to get h of x, I'm going to divide this. H of x is going to be equal to f of negative x. So I look here and I have the absolute value of negative x. That x got replaced with negative x. Plus 3 plus 1. Yes.
So why doesn't it apply to every single one of them? Why is it just the x?
Because whatever sits in this parenthesis is a replacement for only x. Everything else stays the same. Here, this makes the entire function negative, all of it, because it's outside. This means the opposite of f of x. And f of x is this, so we apply it to the entire thing. This says replace the x's in f with negative x, and that's all. So that's what I did. Okay, now we got to pull that little factoring and absolute valuing trick. So remember that, I showed you just a minute ago. I know you just barely saw it, but what we're going to do to this is inside this, we're going to factor out a negative, and it's going to be x minus 3 when I factor that out inside the absolute value. Are you following me? And then we're going to absolute value this separate from this. So it turns out to be the absolute value of x minus 3 plus 1. Because I absolute valued that negative 1 and got a 1. Threw it away, and I have this left. That was that little thing I just showed you a minute ago. Do you recall it, or you want me to show you? Everybody good?
How did it go?
Sarah, you don't look like you're good.
I don't really know what's happening, but
Okay.
You know what I'm saying though?
I'm like,
So you don't remember, I know I erased it. I wish I could go from board to board, but this thing only pick up one board, yes.
so it went from negative x plus 3 to negative parentheses x minus 3. Where did the minus come from?
Whenever you multiply a negative through something, all the stuff inside changes sign. Also true whenever you yank a negative out of everything, everybody's changes sign. Because see, if I were to redistribute this, I would get negative x plus 3, which is what I had. So when I do the opposite and I factor a negative out, everybody's sign changes again. Just like pushing one through, pulling it out does the same thing. And this changed from a negative x to a positive x in the inside, and this changed from a positive 3 to a negative 3, because they're both missing a negative.
You were just putting the parentheses, the negatives on the outside, so that is switch?
Yes.
Yeah.
Do you understand that if I redistribute it, I get this back?
Yeah.
So that means that this is a correct factoring. Whenever you yank a negative out or push a negative through, everybody's sign changes. Because everybody's either got an extra negative now or is missing one. Either way, you have an odd number of negatives yanked out, everybody's sign changes. Does that make any sense?
Yeah.
Okay, no? I saw no. Okay, so then what I did here, to get from here to here, I'm just going to write it kind of tiny in here. I absolute valued that negative 1, and I absolute valued x minus 3. Because of that property, I can split these up. And this is just 1, so I can throw it away.
But why would you throw it away? Well, I guess not.
Because 1 times something is just that thing, and we don't bother to write the 1.
Can I have your attention? They're
Crazy,
ready
huh?
for the sophomores to go.
Lot of math here. Lot of math.
Sophomores, if you
So
have-
this is what you would write for the answer to that one. This is what you would write for the answer to that one. There's a lot of math here, folks. We good so far? Get back as quick as you can. Because I'm going to move on if you're okay. Okay, next thing, example 5 says, let f of x equal the absolute of x minus 3 minus 5. Oh, I can't go there. Okay, so that's our new function, daughter function of absolute values. Let f be that. It says, here's what we're to do. Write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. Wow, that is a loaded bit of information. It's going to take a while to get it into your head, so try to pay attention. If you get lost, let me know. Sarah, don't just give me a frown. Raise your hand. That goes for all of you. That goes for all of you, but I can still tell. Okay, A, a function g whose graph is a horizontal shrink. We haven't done any horizontal shrink stretches or vertical shrink stretches. But notice the word horizontal.
It's gonna be inside.
Takes place inside, and it will be the opposite of what you think. Now, stay with me here. Horizontals, or any kind of stretch or shrink, is a multiplier. When you multiply something, like 2x squared stretches it by 2, the x squared, right? So when you're talking about shrinks and stretches, whether they're horizontal or vertical makes no difference. It's always going to be a number that you multiply. So, since we're in multiplication mode now, instead of add, subtract, what do you suppose it means by when I say the opposite of what you think?
You divide it?
Close, very close. Good thought. It's along those lines. The word is reciprocal. So if you want to shrink it horizontally, it takes place inside. If you want to shrink it by a third, you will multiply by 3. Because it's inside. And opposite of what you think here means reciprocal, since multiply is the operation. I know that's really strange. Shrinks and stretches are multipliers. Opposites of multipliers are its reciprocal. Not adding and subtracting, but multiplying. When you shrink or stretch something, you're going to multiply. You think reciprocal when you think opposite of what you think.
So if you wanted to stretch it, then you would put it
As a fraction. If you want to stretch it by 4, you would multiply by 1/4. If it was horizontal. If you want to stretch it by 4/3, then you would multiply by 3/4. You following? I'm only talking to you two because you're the only ones participating with me. But you see what I'm saying?
Yeah.
Okay. So let's read that again. F of x is this thing I have written on the board. Write a function g whose graph is a horizontal. Pay attention to that word horizontal. Shrink by a factor of 1/3. So this is what I'm going to write. G, this is my intermediate step. G that I'm trying to write is going to be f of 3x. Because it's horizontal, it takes place inside. Because it's horizontal and inside, it's reciprocated. Because we're thinking opposite since it's horizontal. Okay? Y'all follow? And then, knowing what we know about function notation, it means now to write G so that all the x's in f have been replaced with 3x. That's what that means. So it's going to be the absolute of 3x minus 3 minus 5. That's it. You could factor out a 3 in absolute value, and kind of jump, but you don't need to. In other words, if you wanted to go farther, you could do this. You could say that's the absolute value of 3 times x minus 3, if that'll come out. And then we take the absolute value of 3 times the absolute value of x minus 3. I'm sorry, this is a 1. I lost my mind there for a minute, just a minute. I pulled the 3 out. This and this and this, they're all equivalent, but I think that the book and big ideas will accept that. I know I will. Okay? Did y'all follow the process? This is a horizontal shrink of 1/3. That means, this notation means to replace the x's in f with 3x. When that's done and you cleaned it up as much as possible, I mean, this is a little cleaning, but this is a whole. You're done. Yes.
So when you went further and were splitting it up, you pulled the 3 out. What if
If this were 3 and 4, you have no option. But since they both had a 3 in it, I decided to continue. They have to have the same factor, or you have to pull a negative out of everything. You have to pull the same thing out of everything in here in order to continue. This is just a particular case. That's the reason why it's okay to just leave it.
So times that by 3 is shrinking it by 1/3.
Horizontally. Think about this, folks. If you do a vertical stretch, doesn't that make it narrower? If you do a horizontal shrink, doesn't that make it narrower?
It's the same thing.
Yeah. This is, by pulling this 3 out, looks like a vertical stretch, right? Well, it wasn't. It was a horizontal shrink. Now, people at this point say, well, if they're the same, why do we have to have both of them? When you're dealing with quadratics, an x squared, pulling something out doesn't have the same effect as these linear type things. So, a horizontal shrink and a vertical stretch have the same effect, but they are not the same size effect. Most of the time, especially on quadratics. You follow me or not really?
Can I have your attention already? Start freshmen and have your pictures taken, all freshmen, last name
All right,
A through.
let's try the B
F.
part of this.
Go to the auxiliary gym, freshmen A through F.
B part of example 3 says, same function, it says, write a function h, that's going to be its name, whose graph is a vertical, pay attention to that word, a vertical stretch by a factor of 2. Vertical means it will be the opposite or exactly what you think? Exactly what you think. So we want to go h of x, that's our new function, and it's going to be a vertical happens outside, exactly as you imagine it. Vertical stretch of 2 means 2 times all of f of x. And the reason why the 2 is here is because of the word vertical. You following?
Yep.
Now, okay, so now what we say is that h of x is going to be 2 times all of f. That means we distribute. That's 2, absolute. X minus 3 minus 10. It's 2 times this term, this absolute value. You can't get inside there. You can't push a number through that. It's not like parentheses. So think of that as a single package, single chunk. 2 times it looks like this. 2 times that piece looks like that. It's done. That's h of x. You okay? Moving along. Let's look at example 4. This one, we're going to do a couple of things to it. So our intermediate step is going to become longer than just one step. So I'm going to erase this. I hope you've taken some notes. Everybody good or not? Yeah? I'm going to erase this. And we're going to do another one, and we're going to do more than one transformation. But I think you guys are sharp enough to handle it. I'm pretty sure. You're all pretty sharp. I'm pretty confident. Okay. So example 4 says, let the graph of G be a vertical shrink by a factor of a quarter, followed by, more than that, by a translation 3 units up. Okay, so the function is, it's just a regular linear parent. That's nice. So the function we're going to transform is f of x equals x. We're going to do them one at a time, and we're going to call it G as we progress. We're going to do one thing at a time. So the first one says, let G be a vertical shrink by a factor of 0.25. Vertical occurs inside or out? Opposite or exact? Exact. So the first one, I'm not going to call it G yet. I'm going to call it something intermediate, like H. And it's going to be this 0.25 times f of x. Because it's outside and it's vertical, it's exactly what we think. Y'all following? So that means that this is 0.25 times all of f, which is just x. This is my intermediate. That's my intermediate step. So I now have this intermediate function called h. And now to this one, I have to do what's following. So it says followed by a translation 3 units up. Is that vertical, horizontal, positive, negative, exact, opposite, positive? And it's inside or outside? Outside, and it will be opposite or exact? Exact. So G of x, then, is going to be h of x plus 3.
M, to go have pictures taken.
Do you agree?
M.
Whatever we had here is what we have to transform next on the followed by, which is going to be 0.25x. That's h, plus 3. So this one's done. So you have to have an intermediate function here, and then whatever the last transformation is, that's what you do to h. So you do one transformation at a time, and you get one done, and then you transform that one the way the next transformation is, and then you transform that one if necessary. I think you only have to do 2 today. 2 at a time. Last example. This one has some real life context to it. I'll do it right here so I'm erase that over. Okay. Listen to this scenario. Let's see if you can get it in your head. You design a computer game. Okay, cool. Your revenue, does anybody know what revenue actually means? Can anyone define that?
Grand total, how much you make.
Your average of what you make each year.
That's a good, again, incorrect, but listen, I don't want to shoot you down to where you don't participate anymore. Your ideas are great, okay? Yeah, and you were saying something, what were you saying? Revenue?
Is it like the grand total of how much you make out of like a certain something? No.
It's your income. Revenue?
What's the difference?
After they
Okay.
take out everything, so it's like.
Well, what's the difference between revenue and profit then? Because they are different concepts.
Because profit is how much you made off of it, how much money you can make more. Income is the total amount of money that you got.
We're talking revenue.
Can I just look it up?
What? Then what? Somebody wants to look it up?
Can I just look it up?
It says income, especially when of a company or organization and of substantial nature.
What the heck?
Okay. There is a very specific economic definition. Revenue is the amount of money you take in. It's the amount of money in your cash drawer at the end of the day. If you take that pile of money and you pay your employees, and you pay your light bill, and you pay Uncle Sam, and you pay your rent, and you pay for the materials that you brought in that you sold at a higher price because you're a retailer, you pay them. You pay the people that shipped it for you. Anything you have left is profit. And the amount of money that you paid out to all those people is? Revenue was the amount, was the pile of money you had to begin with. What is the money that you paid out to these people called?
Expenses.
Expenses or cost. That's your cost to stay in business. So does it make sense to you based on these ideas that revenue minus cost equals profit?
Oh, yeah.
You're all cool on that. You understand the definitions of these words and how that works out? Okay. So now, let's read it again. You design a computer game. So you got this game and you want to sell it. Your revenue for X downloads of the game, that means for 10 downloads would be X, or 100 downloads, or 1 million, hopefully. Your revenue, the amount of money you take in from the sales, is F of X equals 2X. That's revenue. So I'm going to write it instead of F of X, I'm going to call it R of X. X being the number of games you sold is 2X. What does that mean? What does that, can you tell from that what you're selling each game for? Yes, you can.
$2.
$2.
Good stuff.
2 times every game you sell. If you sold 100 games, you'd make $200. That means you're charging $2 a game. That make good sense? You can tell that. Because if you would understand fully what X is, which is the number of games you sell, twice that number is your revenue. The amount of money you bring in means you're selling it for $2 a game. Okay, so we've got a function. Now it says your profit is. Now we got to translate. P of X. Profit as a function of games sold is. Now we're going to translate very carefully these words. Your profit is $50 less than. That goes back here because whatever comes up here, this is less than. Whatever is here, you got to subtract 50 from it. That's what the phrase less than means. You're going to subtract it from what comes next in the words. Does that make sense? Less than is strange. It reverses the order of things. Less than that phrase. So it's $50 less than whatever I'm about to read, which is 90% of the revenue. Percentages in here always represented as decimals. You never write 90. You write 0.9. You have to be able to convert that easily and without thinking. And you always do it when you're talking percentages. So you understand this translation? It's 50 less than 90% of the revenue. You see at this intermediate step how I put R of X there instead of 2X? Just like I did over here and all the things we've been doing. 90%, $50 less than 90% of the revenue. Do you understand this translation? Okay, so this is our immediate step. So our profit function is going to be 0.9 of 2x, because that's what R of X is. It could be much more complex than this, but I'm going to go with that, minus 50. And we do a little bit of math on that. 0.9 times 2 is 1.8 x minus 50. That's your profit. That's your profit function. Now let me interpret it for you. It said, what are we supposed to do? Oh, what is your profit for 100 downloads? Well, we have a function for profit now for any number of downloads. So the profit for 100 downloads means to do this. Remember that notation? X becomes 100. So we want to find the profit for 100 downloads, as a function of 100 downloads is 1.8 times 100 minus 50. Well, that's 180 minus 50 is 130. Okay? What that means is you brought in $200 because you sold 100 games, your revenue was 200. You only made a profit of 30, which means your cost was 70 bucks. Let me give you just a little bit more insight to that. This part right here where it says 90% and then 50 cents per game, or 50 minus $50, this might have been a startup cost. This might have been to purchase your website or to purchase something to get you online for download, some sort of software or something, and that's a one-time cost. You only have to pay that once. That's the reason why it's out here all by itself. It does not affect your revenue. It's just $50 upfront you had to pay. But then perhaps the company that you're with, the downloading company that you're with, charges 10 cents a game to download it. So you only get 90 cents. Not sorry, 10 cents, 20 cents a game. So you only get 90% of the revenue. That's your $1.80 per game. Minus the 50 bucks to pay the place to get going. Does that make sense? You bring in $1.80 or $1.8. You bring in $1.80 for every sale. You get to keep that. You had to pay 20 cents to someone else for some reason. It's part of your cost. Less the $50 to just get the website running. That's only a one-time deal. That's where this comes from. You can plug any number in here and we'll tell you what your profit, your take home would be after you pay your costs. Does this make sense to you at all? This is the process that we've been learning. They give you a function for revenue. They tell you the profit is some transformation of revenue. You write it down very carefully by translating. Bring that R of X home, whatever it was. Do the math on it. And then you have a function you can use to predict any profit for any number of downloads. This is a specific one. This is the general one. This is your profit function. This is your profit for 100 times. It's all really cool. It all is reasonable. I hope. I was hoping to do 2 sections again today, but of course I get too long-winded. And there you go. So there's just one assignment today. And if it's already in your Big Ideas Math, you may have already started it. But for those of you doing it on paper, I'm going to listen while I read to you the assignment. Ready? I'll wait for you. I'll give you a second to find something to write on. Remember, you're going to put the section number nice and big and wide in the upper right-hand corner. 1.2. And these are the problem numbers. 1, 3 through 8, 10, 11 to 29, odd, 30, and 33 to 35. And this is not on the Big Ideas assignment, but this goes for all of you. If you are interested in extra credit, which is points which add to your test score, so you're interested in that. It's not very many, but every once in a while I give an extra credit question because I think it's really cool. Good question, challenge your mind, but it's not really necessary for you to know how to do. So number 41 is extra credit. And if you wish to get that extra credit, you will have to turn number 41 on a completely, totally different sheet of paper. So if you choose to do 41, what you would write on your paper, and the only thing I want to see on that paper is number 41. You would write somewhere on it, extra credit, number 41, section 2.1, and then show me your work. You have to show me how you came up with it. You can't just give me an answer to get credit. And if you're right, I'll add 2 or 3 points to your percentage on your next test, if you get it right. But you have to turn it in before test time.
We're ready for freshmen M through F, to have your picture taken, freshmen M through F.
All right, now I hope you were able to see that. I know there's a glare on the board, but I don't know what else to tell you. I can't do away with that. So once again, give me a call if you have any questions. Hope this worked out well for you. Bye.